this video, I'm going to create a machine learning model to predict employee attrition using AutoML. The first steps are with an autonomous database to create a user account for this demonstration. We will call this user account OML user, and it will be used to perform a data load and also to create the machine learning model using AutoML UI. So I'll give the user the name and pass it a password. In addition to this, we'll also need to provide it OML access and access to the web. Provide it with unlimited access in terms of creating rows. Now, once the user account's been created, what we're then going to do is to load some example data that I've obtained that includes details of employees and whether they left the organisation. This is synthetic data that was pulled from Kaggle. So we'll go into data load. We then need to ensure that we're logged in as the OML user that we previously created. So we'll log in using this account. And then what we'll do is we'll take the synthetic data that I have on employee attrition, load it into the database in preparation for creating a machine learning model from it. So what we'll do here is go to Data Studio and then to Data Load. We'll select Load Data. And what we'll then do is take the CSV file that I've got with the synthetic data obtained from Kaggle and pop that in there, which will analyze the data and will then look to perform a load. Before we do that, the one small change I want to make is to just change the name of the table that it'll create to store the data. I'll remove HR and essentially just call it employee attrition. Beneath it, you can see all of the columns that will be created as part of this import. I'll then click Start, which will take the CSV data and import this into the autonomous database. Now you can see that completed rather quickly due to the time lapse. So now we've got the data. The next thing I want to do is to just take a look at the data to ensure that it's imported correctly. So if we just run this query now, we can then see the rows have been returned. For each employee, you can see various data points, including attrition. If attrition is yes, it essentially means that the employee left the organisation. What we'll then do is log into machine learning, and we'll look to create the AutoML machine learning model. So I'll sign into the OML user that I created previously, select AutoML. I'll then create an AutoML experiment. We'll call this experiment employee attrition. And what we'll do is point this towards the data that we've just loaded into the autonomous database. So I'll select the OML user schema and the employee attrition table. Once I've selected that, it will give me the option to choose a prediction target. In this case, it's attrition, which is a yes/no Boolean value. Essentially, I'm wanting to predict whether an employee will leave. It will then also select the prediction type as classification. I can then select a case ID, essentially a unique identifier. For this case, I'll use employee ID. We can take a look at the additional settings, but in this specific case, these will not be changed. I'll essentially just use the default values that are available. I'll then start the experiment. I'll go for better accuracy, which may take slightly longer, but as the name suggests, means the results will be more accurate. In a few minutes, the experiment should complete. What the experiment will do is run the data through various machine learning algorithms and put them in rank and order. So essentially, it does all of the hard work for me. I can just sit back and then look at the results. And based on the results that have come back, I can select an appropriate model based on an algorithm to publish. We can see here that it puts them in order. The higher the number, the better. So we'll go for the one at the top. And if we click into it, we can see the various data points that actually drive the prediction. So here, there are several data points that can help influence it, including overtime, total working years, and job involvement, which are the top three. So that's pretty good. What we'll then do is deploy this to a REST API endpoint so that we can call it externally. For this, we give it a name, which I'm going to call it emp attrition, nice and short and sweet. I'll give it exactly the same name to the URI that we'll call, give it a version number, give it a namespace. In this specific case, I'm just going to call it demo, put shared so that other users can potentially call the model, and then hit OK. Once the model's been deployed, I then have a REST API endpoint that I can call. I can pass data to the model, and from it, it will make the prediction based upon the classifications that we have. In this specific case, does the employee want to leave or not? If we look at user models, we can see all the models that were created as part of the experiment, and then we can also see deployments, which lists the model that we did actually deploy to the REST endpoint, as you recall, which was the one at the top of the list. If we click into the URI of the experiment, we can get the OpenAI specification for it. Here lists various data, including the information that we can pass to the endpoint in order for it to make a prediction. The next thing that we will do is put together a Python script that will call the REST API endpoint that was created so that we can then pass it data, and in order to do that, get a prediction. What we need to do as the next step is to go into database actions and go to Oracle Machine Learning RESTful Services, copy the 3 URLs that are included here because we will need them for the Python scripts that I'll create later to actually call the endpoint. Okay, now we've got our machine learning model created, the next thing for us to do is to test it. And what we'll do is we will run this Python script that will make a call against the model and make a prediction whether a specific employee will look to leave the organisation. Now, the prerequisites for the script are 2 separate URLs, one for authentication and one for the actual endpoint for the model that we've published itself. And the way to get these, as I touched upon earlier, is to go to the Oracle Machine Learning RESTful Services, and we need the top URL, which is for the authentication endpoint, and the bottom URL, which is used for the actual API that we've published. In addition to that, we need the name of the model, and if you recall, we called the model attrition. What we'll then do is grab an authentication token, which uses this top URL here. So this will authenticate to Oracle Machine Learning using the AutoML user account that we created, that did the data load and also created the model itself. And here I'm with my placeholder password. Now, once you have authenticated to Oracle Machine Learning, you're then able to make calls against it. And what we'll do here is I've handcrafted a request that will pass some very specific attributes for an employee to the model to make a prediction as to whether they're likely to leave the organisation or not. So the key interesting piece here is this piece of JSON, which includes 3 pieces of information about an employee. 1, did they do any overtime? Secondly, how long have they worked for the company? And lastly, how often do they travel? Now, what happens if we send this information to the machine learning model? Based upon those attributes, it will make a prediction as to whether the employee is likely to leave the organisation or not. So what you'd likely do in a real-world scenario, the model would have been created using real-world data from your organisation. You train the model, and then moving forwards, what you'd likely do is put existing employees through the model to help predict whether they're likely to leave the organisation or not, so you could take some proactive actions to stop that. So what we'll do here is we'll pass this to the machine learning model, and what it should do is provide us a prediction for this specific employee as to whether they will be likely to leave the organisation or not. So I'll quickly execute this now. And what we can see here, the probability of them leaving is very low, at about 22%, and the probability of them staying is very high, at around 77%. We can do a second experiment here, where we run the same query again, but essentially in this specific case, we have a slightly different employee, one that does overtime, has been at the company slightly less time, so 5 years rather than 10, and that also travels quite frequently too. And if we run that specific employee through the model, it will give us a prediction. And here we can see the predictions slightly different. So the likelihood of them leaving is 71%, and the likelihood of them staying within the organisation is 28%. So obviously this is a user, the employee, that you would probably want to spend some time understanding why, and maybe taking some proactive actions on that. A key thing to point out about the information that you provide to the model, you don't necessarily need to provide all of the fields. You can provide as few or as many fields as you wish. However, the more fields of information you can provide about that specific employee or data point, the better. If you recall earlier when we took a look at the model after it had been trained, it did provide a breakdown of all of the columns and also which ones were most important in terms of influencing the classification decision. So for this example here, I've taken kind of the top 3 that do influence whether an employee is likely to leave an organisation or not. So that's just one top point. I will include a link to the script that I've put together that you can use to test the model below, so you can start to have a play around with it yourself and experiment with Oracle machine learning. Hopefully this video has been informative. It's helped you realise that creating machine learning models isn't overly complex. It's something you can do in a short amount of time, and again can start to query it. In this specific case, I've used Python, but in a real world you probably have a nice custom front-end application that did some analysis and visualization of it. Personally, I've used Oracle Analytics Cloud, and in a future video I'll step through how you can hook up Oracle Analytics Cloud to a machine learning model. But thank you so much for listening. Really appreciate your time.